Hello everyone. Today, I'd like to share some key points about the practical application and installation of tapered roller bearings. Instead of sticking strictly to theoretical explanations, I'll draw from years of hands-on experience guiding customers through on-site installation and application, aiming to present the information in an easy-to-understand way that can be genuinely helpful. The outer ring of a tapered roller bearing has a sloping design, which is mainly intended to withstand greater one-directional axial loads. The steeper the slope, the higher the load capacity of the bearing. Simply put, axial force refers to the front-to-back or up and down force generated by the shaft during operation, while radial force is the load borne by the bearing in supporting the shaft vertically. Both types of loads are commonly encountered in real-world applications. So how does a tapered roller bearing handle both radial and axial loads simultaneously? In general, we use two identical tapered bearings in pairs, typically mounted either back-to-back or face-to-face. As industrial equipment continues to demand higher load capacities, bearing structures have also been improved. For example, double-row and even four-row tapered roller bearings have been developed. In terms of materials, there has been a gradual shift from standard bearing steel to more wear-resistant and high-strength materials such as perturvia carbizing steel. When it comes to installation, batch installations by OEM customers usually don't pose major issues. However, for on-site installations where specialized tools may be lacking, extra attention should be paid to the following. Pre-installation preparation. After removing the old bearing, be sure to clean off any residual grease and metal debris. Check the shaft and housing for wear. If damage is found, repair it first and take multiple measurements to ensure the new bearing's installation dimensions meet requirements. Handle with care. If the bearing is heavy, avoid dropping or mishandling it, as impact can damage the raceway and roller contact areas. Thin outer rings may also become oval-shaped under rough handling, affecting precision. Choose the right installation method. Common methods include cold mounting, hot mounting, and hydraulic installation. Select the appropriate method based on site conditions. Note that some degree of tapping may be necessary to seat the bearing fully. However, never strike the inner ring edge or the cage directly. If the cage deforms, the rolling elements may not run smoothly. Moderate lubrication is key. More grease isn't always better. Just make sure the bearing contact surfaces are evenly coated, and that the grease type meets the equipment's requirements. Pay attention to preload. Tapered roller bearings usually require preload after installation. If using a set screw for preload, it's advisable to tighten it and then loosen it slightly to allow the bearing some self-adjusting clearance. For end cover preload structures, ensure the outer ring is firmly seated without any axial play. These are some practical insights I gathered from hands-on work. I hope they serve as a useful reference. If you have better suggestions or different perspectives, I welcome your feedback. Thank you for reading.